Let's begin by looking at our lesson objectives for this review. We'll learn to identify ionic and molecular compounds, practice naming ionic and molecular compounds, and lastly, review the rules for naming ionic compounds with Roman numerals, which can be an extra tricky example. First up, recall that ionic compounds are made of metals and nonmetals combined together. And the periodic table is your best way to determine if something's a metal or a nonmetal. Things on the left side of the periodic table, those are metals, and things on the right side are generally nonmetals. So to imagine this on a periodic table, you can think of a stair step going down from boron that divides the periodic table into metals on the left and nonmetals on the right. Let's apply this to a particular compound. Say we have FeO2. Notice that Fe, that's iron, shows up on the left-hand side of the periodic table. It's a metal. And oxygen shows up on the right-hand side. It's a nonmetal. So given that we've combined a metal and a nonmetal, this will be an ionic compound. So ionic compounds are metals and nonmetals combined together. Meanwhile, molecular compounds are two nonmetals that you've crammed together. So for CO2, which is a molecular compound, notice that carbon comes from nonmetals and so does oxygen. Now, this is important because ionic and molecular compounds are named differently. Let's practice identifying ionic and molecular compounds. In reviews like this, we'll very often pause and let you work a problem. So here's your first chance. Pause the video and identify each one of these options as ionic or molecular. Then we'll proceed to name them in just a second. Let's take a look at the answers. A is molecular because both phosphorus and fluorine are nonmetals. B is molecular for the same reason, those are two nonmetals. C is ionic because aluminum is a metal while oxygen is a nonmetal. D is ionic because we've mixed metals and nonmetals. And lastly, E is molecular because once again we have two nonmetals. All right, now is your chance to actually practice naming these. Why don't you review your notes from naming ionic and molecular compounds, pause the video, and try your best to name these. All right, let's go over the answer for the very first problem. A should be named phosphorus tetrafluoride. Tetra means four, so it's named tetrafluoride because there's four fluorines. Meanwhile, B should be sulfur dichloride. That di comes because of the fact that there's two chlorines. Okay, if you didn't get those right, then go ahead and pause the video and try to correct your next three. Then we'll look at those answers all at once. The answer to the last three is aluminum oxide, lithium fluoride, and dinitrogen tetraoxide. Notice you see these prefixes throughout the names that indicate how many of a given element we have. But you don't see those for C and D, and that's because those are ionic compounds. Here's an important rule. Only use di, tri, tetra with molecular compounds, never with ionic compounds. Okay, let's move on to thinking a little more about naming ionic compounds. One important skill for naming ionic compounds is being able to predict the charge of ions. And remember, we can do that with our friend, the periodic table. Everything in that first column has a +1 charge. Hydrogen, lithium, sodium, potassium, rubidium, all would have a +1 charge in an ionic compound. In the second column, we get +2, and then maybe you remember the rest, which we'll put up all at once. +3 for that column starting with boron, -3 for nitrogen, -2 for the oxygen column, and -1 for the fluorine column. Here's the deal though, a lot of those elements on the periodic table you can't predict the charge for. And if you can't predict the charge, you have to use Roman numerals. Very important. Can't predict the charge? You must use Roman numerals. Let's look at an example of that in detail. Here we have FeO2. And we know the charge on some of these elements. For example, oxygen is in the -2 column, so no problem there, oxygen is -2. Fe, which is iron though, and a metal, is right in the middle of that area called the D block where we don't know the charge. So we don't know the charge on iron. And that means if we want to name it, we know we would name it iron oxide, but we need to indicate the charge with Roman numerals right where those question marks are. So remember, what the Roman numerals will do is they'll indicate the charge on the cation. The Roman numerals indicate the charge on the cation. The big question then, of course, is what Roman numeral should we use? Let's practice figuring this out. Here we have FeO2, and we've kind of set up two stacks of elements. On the right, we've put our anions, the oxygens, and there's two of them. And on the left, we've put iron, that's our cation, and there's just one of them because there's only one iron in this compound. Now the charge on each oxygen is -2. We know that from the periodic table. And when I add those two up, it gives me a -4. Remember that ionic compounds must be neutral overall, so when I think about what the total positive charge must be, it has to be +4. And that means that the charge on my iron must be +4. So +4 is the charge that's going to tell us what Roman numeral we should use, which is 4. So the correct name of FeO2 is iron 4 oxide. Really quickly, let's look at the Roman numerals. We see 1, 2, 3, and then 4 is IV, which is kind of the trickiest one. But what that means is V, which is 5, and we take away 1 to get 4. And then V is 5 and VI is 6. Okay, so those are the 6 Roman numerals you kind of need to know that will come up fairly regularly when naming ionic compounds. All right, let's practice identifying compounds that need Roman numerals, because one common problem students have is not knowing when to use them. So let's look at all of these compounds, A through D, and what I want you to do is pause the video and identify which one of these compounds will need Roman numerals. All right, well, it turns out A, FeO3, will need Roman numerals because iron is in the D block where we can't predict the charge. Nickel in NiCl2 is similarly in the D block, and we can't predict the charge. Lastly, Pb, which is lead, we can't predict the charge of that compound either. So, because we can't predict the charges of these compounds, we're going to need to use Roman numerals to name them. Now what I want you to do is go ahead and try your best to name these compounds and grab the correct Roman numerals. All right, I'm going to give you the answers now. So A should have been iron 6 oxide. B, potassium bromide. We don't need a Roman numeral there because we can predict the charge on potassium. C should be nickel 2 chloride. And then lastly, D should be lead 3 oxide. My guess is if you missed one of them, you missed D. D can be a little tricky. Let's take a look at how we figured out that 3 for the Roman numeral. Here we have our stack of elements. Our oxygens, each at -2, add up to a -6. So lead must be +6, and that means each individual lead is +3. So that's how we got lead 3 oxide. Let's review what we've learned. First, we learned to identify ionic and molecular compounds. We saw that ionic compounds are made of a metal and a nonmetal, and molecular compounds are made of 2 nonmetals. Then we practiced naming ionic and molecular compounds. Lastly, we reviewed the rules for naming ionic compounds with Roman numerals, and we practiced figuring out what Roman numeral we should use. Hey, hey.